A blood clot is a hemostatic mechanism. A hemostatic mechanism, or hemostasis, is a process that stops bleeding. You can even hear it in the word, the prefix hemo pertaining to blood, and stasis pertaining to stability or stopping bleeding. There are three major hemostatic mechanisms. One is vasoconstriction. Vasoconstriction is just when smooth muscle cells in the walls of a blood vessel constrict. That decreases the diameter of the blood vessel, kind of like pinching a hose when water is moving through. That's going to reduce the amount of flow through the vessel, therefore reducing the amount of blood leaving the damaged vessel. The second major hemostatic mechanism is a platelet plug formation. Remember that platelets don't stick in their natural environment. In other words, platelets don't stick to the endothelium that's lining all blood vessels. Endothelium also lines the chambers of the heart. So if ever platelets are exposed to something other than endothelium, such as the connective tissue below endothelium or a foreign surface, automatically they'll stick. Those platelets that stick secrete serotonin and other chemicals that cause more platelets to stick, and they form a plug. That platelet plug alone can stop blood loss, but it's just not very strong. It's only a temporary structure. So to strengthen the platelet plug, what we need to do is we need to have a soluble protein in the blood called fibrinogen precipitate out of solution into its fibrous form called fibrin. Fibrin can weave through the platelet plug, strengthening it, making it strong enough for red blood cells to stick. That's what's called a blood clot. In this electron micrograph, you can see the fibrin that's precipitated out of solution. It looks like cobwebs. So how does fibrin precipitate out of our plasma? How does it go from being soluble protein to an insoluble fiber? And the short answer to that is that fibrinogen will precipitate out of solution in the presence of thrombin. So in the presence of thrombin, fibrinogen will precipitate and become a solid fiber called fibrin. Longer answer to that, how do we get thrombin coming out of the blood? There are two ways that could cause the formation of that final pathway of thrombin precipitating fibrinogen out of the blood into fibrin. One is called an intrinsic pathway, one is called an extrinsic pathway. Basically, taking a look at the intrinsic pathway, notice how many steps are involved. There are a higher number of steps. In other words, this is the long way. Contrasting that to the extrinsic pathway, fewer number of steps. That's the shortcut. Let's take another look at the intrinsic pathway. The intrinsic pathway doesn't have anything extra put into the blood. So in other words, everything that has to be there in order for the blood to clot is there. It's an innate ability. That's intrinsic. Versus extrinsic, look at the top of that pathway. They're showing me something called tissue factor. What is that? Tissue factor, or tissue thromboplastin, is a chemical that's added to the blood from the damaged tissue. It's like an SOS message from the damaged tissue. Tissue factor is going to speed up the number of steps required to get to the bottom of this pathway. In other words, if damaged tissue secretes an SOS factor, like tissue factor, then that's going to speed up the process of clotting. If nothing else additional is added to the blood, like in the intrinsic mechanism, or if tissue thromboplastin is added to the blood as an SOS signal and it speeds up the process, either way, what will happen is the same thing, that prothrombin is converted to thrombin, and that thrombin will convert the soluble fibrinogen into the insoluble fibrin, and that's what we need to form a blood clot. Once a blood clot is formed, there'll be what's called clot retraction. That's when the platelets constrict. It reduces the volume of the clot and it brings the borders of the injured tissue closer together. And eventually fibrinolysis is when the blood clot dissolves over time. Let's finish up by taking a look at the notes. We're at the bottom of page 5. There are 3 hemostatic mechanisms that we looked at in the video. Because we have a finite amount of blood, any blood loss has to be minimized, and we do that through vasoconstriction, platelet plug formation, and blood clot formation. A platelet plug is when platelets stick to any foreign surface. They release a substance which will cause other platelets to stick, and it forms a plug, or platelet plug. A platelet plug, once it's formed, can be stabilized into a blood clot. What we need for that is the addition of fibrin, a protein that's always present in its soluble form in the blood. There are 2 mechanisms that can precipitate fibrinogen, the soluble plasma protein, into the fibrous strands called fibrin. Those 2 mechanisms are the intrinsic pathway, which is the long way. Those steps require calcium, but they don't require anything to be added to the blood. The other process is called the extrinsic pathway. That's the shortcut. Those steps require calcium too, but they need an additional chemical called tissue factor to be secreted by damaged tissue into the blood. That will speed things up. Either way, both the intrinsic and the extrinsic pathways will lead to prothrombin activator being formed. Prothrombin activator will convert prothrombin into thrombin, and thrombin is the substance that will convert fibrinogen into fibrin. Once fibrin is present, fibrin will weave through the platelet plug, strengthening the platelet plug enough so that red blood cells can stick, and that's what we call a blood clot. Once the clot is formed, platelets will contract, reducing the size of repair. Repair will occur, and eventually the clot will dissolve over time. That's known as fibrinolysis.